It's the language of the universe.
But I don't understand it.
Hello, everybody, and welcome back to another episode of the Math and Physics Podcast. I'm your host, Parker.
And I'm Ray, and we welcome you back to episode number 94, where today we are joined by fellow author and inventor Clement Decrop. So, Clement, how are you today? You want to maybe give a quick little introduction to yourself to our vast audience here?
Dude, of course. First of all, thank you for having me, Ray and Parker. I'm excited to be here. So my name's Clement. I was born in Belgium, then I moved to Spain, then I moved to the US when I was around 6. Then I went to a small middle school with around 23 kids, then to a high school with 600 kids, then went to Penn State that had 10,000 kids in my grade. So, whoop! Did mechanical engineering. After mechanical engineering, I wanted to do consulting. And a lot of the recruiters told me I didn't have any financial experience. And I was like, well, I just did mechanical engineering. How was I supposed to get financial experience? So then after that, I did a 1-year master's program at Penn State and then worked at IBM where I worked on IoT projects, a couple kind of data analytics role, did some patenting, like I told you guys before this. And then also worked on a large sales presentation for the NSA, which was pretty interesting. But after all that, I was like, there's more to life, right? I was just working at a job and I put so much work in on what I was doing and I wasn't getting any direct reward. So I was like, what if I just bet on myself, right? What if I just went all in? So I went on leave for this past year and I wrote a book called The Idea Space, which we'll talk about a little bit, I'm sure.
100%.
So I wrote that, finished it, and now I'm working on all the different marketing aspects of it. But the big question was I was super interested in math and physics. This is why I did engineering. But then I was just how does math apply to consciousness, right? How do we take the concepts of groupings and countability versus uncountability and apply that to the mind in a way that's cohesive and congruent with modern physics, right? And that was kind of the birth of an idea space.
Mm-hmm.
That is,
and that's also something that we've touched on, I guess. We've done a couple of episodes on philosophy and we talked about consciousness, but I guess we've never really gone into it as far as you have, having written an entire book on it. So we're really excited to get to know a lot more about the idea space and all the awesome mathematical and physical ties.
Because usually when we talk about this level of philosophy, we're talking very philosophically and just from a perspective of, hey, we're interested in this unknown world of consciousness, so let's explore it a little bit just by asking easy logical questions. But you're taking it to the very next step and actually getting in the physics of it. So I'm actually quite excited to hear about the physics of such a philosophical element. So I'm very excited for that. It's going to be fun.
Yeah, it's all about getting a common layer of understanding, right? Something Richard Feynman talks about a lot about physics is an approximation of the world around us, right? So how do we approximate consciousness?
Also, I'm so sorry by completely butchering your name. You said it was Clement.
Dude, don't sweat it.
I'm
so hard.
Sorry. I noticed it when you said it, and I'm I can't not say anything about this, so I just had to mention it.
Good, man.
So let's introduce the podcast a little bit. Some news before we get straight into it.
So really quickly, the giveaway is live on our Instagram at math.physics.podcast. It went up yesterday, so we're going to announce the winner in exactly 1 week from now, so make sure to go and
episode
join
95.
that.
Yeah, episode 95, it will be announced, so just drop it all the way until Sunday of next week, so you guys have time. And yeah, who knows? It's going to be a fun.
And we're also doing
giveaway.
one giveaway every episode for the next 8 episodes. So we're going to announce the winner and another giveaway every single episode. So stay tuned for that. Also, really quickly, we have the comment of the week. This week comes from Black Star Studio. They say, I really enjoy what you guys have created. I've always loved physics, and I've always been afraid it would be too hard. This is my last semester of psychology, and I'm going to continue and earn a physics degree also. I wish I would have done that from the start. Listening to you two talk and share your love for physics is really inspiring, and I look forward to seeing great things from you guys in the future. So thank you so much for that
Wow.
amazing comment. And
Love to hear
if you want to be next week's comment of the week, go to our YouTube channel. And under this video, you can leave a comment and you might be next week's comment of the week.
Yeah, super simple.
Congrats.
Updating you guys on the news a little bit. On our downloads, we're nearly 400K. We're at 375 right now. So that's a pretty big moment. 500 is going to be so amazing. I'm so excited for that. So thank you for everyone to continue to download our podcasts. And as you all know, Spotify now has a rating feature. So go ahead and rate the podcast 5 stars, if that is obviously how you feel. I should say that. On our YouTube, we're popping off with 2,200 subscribers. I think the YouTube subscriber count is a little weird because there are like multiple. It's a little messy with the creators these days, but it's around 2,250. So thank you to everyone who continues to listen to us, watch us on YouTube, because we're I guess an audio and a video podcast now. So I guess that's basically it. I don't think we have any more news, so we can just get into the podcast very simply. Clement, you already kind of given us your little bit of a backstory into how you briefly got into it. But how about I officially ask you, how did you get into this world of engineering, physics, and math? And especially, how did it end with you writing this book?
Yeah, well, first off, congrats on all the awesome accolades. You guys are killing it.
Thank you.
Thank you.
So to answer your question, I was always a nerd. I love doing Rubik's Cubes and all the nerd stuff.
Oh, yeah.
So,
Me too.
so I just like continued down that path. I really wanted to know how the world worked on a fundamental level, right? Like, what are forces? How do forces work? If I push a lamp this way, why does it go that way, right? And I just kind of like continuously wanted to learn, right? Wanted to deeply understand how the world worked on a fundamental level. And then it got to a point where when I was working, I was like not learning much more. So I just bought a bunch of books. And I think books are really important because they're kind of like a melding of idea spaces between like the author who wrote it and then the person reading it. And I read Abstract Algebra by Charles Pugh, who was a Berkeley professor, which is an amazing book on just how to think in terms of proofs and like math and just analysis in general. And then I read the David Dummett and Richard Foote's masterpiece called Abstract Algebra, which is just a behemoth of a book, but it just talks about algebra really well and kind of like the structure of groups and rings and all that fun stuff. But then I also love physics. So like, how do I expand my breadth of physics? And then I just kept reading as well, right? Books are the best way to learn. I read a lot of Sean Carroll. He's an idol of mine. Read the Richard Feynman lectures online, which are like the top lectures anyone can read. And then I wanted to go deeper. So I read The Large Scale Structure of Space-Time by Stephen Hawking, which is a masterpiece. And then I also, there you go. Sean Carroll's the man. And I like Sean Carroll too because he's like philosophical.
Yeah.
And then the last book I read that was really nice was The Early Universe by Michael Cobb and Edward Turner, I feel. Or I might have mixed up their names. But that was all about like the Big Bang and kind of like if general relativity gives you the framework for how the universe works, quantum mechanics tells you how to like the stuff inside the universe. So that's kind of like how I got there. And then I was just like, I loved mindfulness. I thought that was a really important tool for just growth, personal growth, and then just also like relationship growth in all aspects of life. And I really thought that that's what was missing in today's physics, right? Like, how do you talk about consciousness in a way that uses the same language as we talk about stars, physics, and like space and time? So that was kind of like the birth of the idea space. Yeah, great question.
Wow.
That's awesome. So you've written the book called The Idea Space. Now, for all of our listeners out there who are probably saying, what the hell is an idea space? Give us a brief little introduction to what is the idea space.
Yeah, another great question. So an idea space consists of your thoughts, emotions, sensations, and perceptions. So thoughts includes words, pictures, songs. Emotions includes pleasant, unpleasant, anything in between. Sensations are the classical 5 sensations, right? And then perception is just the ability to recognize something. So like I see a mic, I know that's a mic, right? So those are the elements of consciousness, and those are the elements of an idea space. Another element of an idea space is the null set. So if you're not familiar with the null set, it's just nothing, like nothing at all. So if something is like missing in a table, it's the null set. There's just nothing there. So those are the elements of the idea space, and then there's also an identity to an idea space. And the identity of an idea space is essentially the one thing you'll remember out of an idea space. So if you're listening to this live, right, you're probably kind of like listening to a whole lot of conversation, and then at the end you're going to have a takeaway, right? And what is that takeaway? That's going to be the identity of your idea space. So that's kind of like the fundamental properties of an idea space, but from there we can get into the more mathematical properties, which are the idea space is uncountable and the idea space has zero measure. So having uncountable is a doozy of a conversation, but the basic way to understand it is to relate it to something else that's uncountable. So according to general relativity, it's how we measure stuff is based on the real numbers, right? And the essential argument is this, right? Let's say that you have your x-axis is like looking right in front of you, your y-axis is looking to the right, and then your z-axis is looking straight up. Essentially, imagine you have a ruler that's coming out in your x-axis and it just extends for however long you want. And you can make any single measurement that you want, 2.23, 5.68, 0.2342, whatever you want, right? Let's say that you list an infinite amount of them. The whole argument is, and this was developed by a guy named Gregor Cantor in the late 1800s, is that for any for any measurement that you make, I can always pick a measurement that you did not make, right? And the basic gist of it is basically saying you introduce a new number where the first decimal point of that new number is not equal to the first decimal point of your first measurement. Then the second decimal point of that new number you introduce is not equal to the second decimal point of that second measurement that you make. And then you just keep iterating this until infinity. And you get a new number that wasn't in all your infinite amount of measurements. So uncountability and the real numbers being uncountable just means that there's a larger size of infinity, right, with the real numbers than the natural numbers, the rational numbers, and the integers, which are a smaller size of infinity.
So where does the whole premise of the idea space being? I don't think that point has really honed in with me yet. If you want to give that another shot, like where comes the point of the idea space being uncountable?
Definitely,
I'm just trying to understand between like uncountable or like, is it countably infinite? Is it countable but you know what I mean when I say like countably infinite as well, right? They're all like mathematical ways to describe, because countable and uncountable might seem like, oh, they're just words in English, but in math they're like vastly different things. So I just want to ask you, maybe hone in on that point a little bit. What makes the idea space uncountable?
Yep. So I'll give the intuitive argument, and then I will go into the math of it, because I think that'll be interesting too. So again, the intuitive argument for why space-time is uncountable is because there will always be a measurement that I can make that you did not make. So for the idea space, the argument is that there will always be an idea that is had that wasn't had before. So this can be based on the proposition that each discovery has a new idea or a new question, right? And to give a more concrete example is, let's say you're living in 1680, right? Pre-gravity. And let's say you try to count all the idea spaces of everybody that's living right there. You just get an infinite amount, right? But then in like 1686 or whenever Newton dropped Principia Mathematica, the new idea of gravity came, right? So where was that idea in the infinite list of ideas before, right? It wasn't there. And you can get like the same concept goes with idea spaces, right? Like before you guys heard of an idea space, you had like all these thoughts and you could count all the infinite amount of ideas. And then a new thought comes in, the idea space. Where was that before in the infinite amount of ideas? It wasn't there. So that's kind of like the intuitive approach. For a more mathematical approach, like what does it mean to count, right? So in order to count something, there has to be a bijection between the natural numbers and whatever set you're counting. So again, the natural numbers are just 1, 2, 3, 4, 5, so on and so forth. What is a bijection? A bijection is an injection and surjection. And what are those two words? Mathematicians have the best language.
I love this.
So an injection is basically a one-to-one function. So for every A, there is exactly one B. But not the whole domain of A doesn't have to go to the whole domain of B. So for example, if you have 4A and 5B, just every A has to go to 1B exactly once. That's onto. That's one-to-one. Something that is surjective or onto is all of A maps to all of B, right? And a bijection is something that is one-to-one and onto. So that's basically, if there's 5 elements, imagine you have 3 dogs and 3 cats, right? And the first dog maps to the first cat, the second dog maps to the second cat, and so on, right? And you have a bijection. There's a one-to-one relationship that maps both the whole domain and range. And when you count something, the thing that's interesting is that if there's a bijection, then there's the equal amount of elements, right? If there's a one-to-one relationship that is onto, then they'll have the same amount of dogs as there are cats, right? So bringing this all together, something is countable if there's a bijection between the natural numbers and what you want to count. So what you're essentially saying is that the idea space is uncountable because there is no bijection between the natural numbers and the amount of ideas. Because if we did it like the same example that we looked at, like in 1680, we count all the different ideas, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where was gravity in that? It wasn't there. So there's no bijection between the natural numbers and the idea space, and therefore it's uncountable.
So are you saying that the idea space is the union of everybody's idea spaces?
Fantastic question. There's two types of idea spaces. There are personal idea spaces and macro idea spaces. Personal idea spaces are idea spaces that you and I live in right now. Like, you guys are looking at me, you guys have your own thoughts, and no one can see those thoughts, right? It has zero measure, right? And intuitively, zero measure is like, let's say you have a pen and it just shrinks, and it shrinks to a point where it just kind of vanishes, right? That's something that has zero measure. But the trick is that you can have something that has zero measure looks like nothing, right? If I got out a ruler and I tried to measure zero measure, I would get 0. If I got out a ruler and I measured nothing, I would get 0. But you can have something that has zero measure and be uncountable, which is the idea space, right? So you have your personal idea space, which is kind of the one that we're living in, that you're just like living in just with your own thoughts. And then you have the macro idea space, which is the one that you get from just talking to people, like you and I are doing right now, right? We're just like building this imaginary globe of ideas that's creating like unique content and creating new ideas that weren't there before.
Yeah, consciousness is really cool in this way, because I think on a previous episode, Parker and I were talking about, I think this was on the Do You Even Exist episode, where I think it was Parker that gave the idea that if like we all are connected. Oh no, was it this episode? Anyway, there was some episode where we were floating the idea of physical reality. Yeah, I'm pretty sure it was this episode. Physical reality and consciousness being separated, like the mind-body problem. And the whole question was, or the whole topic of discussion was, well, can we control or can we reach to this conscious space? And like now thinking about it, that's literally the idea. Like your idea space is basically how you define, or how we were taking it to be, like, hey, are we all just separately connecting to this consciousness, right? So basically what you're doing is you're finding a way to mathematically describe what we think of. Is that semi-accurate?
Yeah, that was very well stated. And I like a good point you said, where it's like you have mind-body duality, right? And that's like such a big problem in like just all humans, right? Like, are we controlled by the mind, or are we controlled by the body? And like, I think Sam Harris had a good quote where it's like, in order to solve mind-body duality, you need to introduce a neutral element to describe it. And I think the neutral element to describe it is clopin, this concept of something can be open and closed at the same time.
Explain that in terms of the idea space. Explain that in terms of the idea space, because I want to,
Yeah, for sure. So a metric space is a way to define distance in between 2 points, right? So your typical distance is Euclidean, right? X squared plus B squared, X squared plus Y squared plus C squared plus Z squared is your distance, right? But you could also have like a discrete metric where it's like the distance between any 2 points is 1. And you could also have a pseudo-metric space where the distance between any 2 points is 0. So the way that you can group things, it can be open, closed, clopin, or neither. So let's think of a circle that's like filled. Imagine that you have a circle and it goes all the way up until the boundary, like a radius of 1, but it doesn't include 1, right? That's open, right? It's like if you ever play video games and like it lags and you're walking up against a wall and it's just like, that's kind of like open. Closed is like that same circle, except when you hit the circle, it includes 1. So if you're playing that video game, you just kind of splat up against the wall. So then the question, you can have something that's like neither. So it's like half open, half closed. So think of a circle where the left side is closed, but then the right side is open. And then you have this magic of clopin, right? So how do we get to clopin? So let's say that I have the number line 1 through 5, right? And it's closed. And let's say I take away the open interval 1, 2, right? What would I be left with? If I take away the open interval 1, 2, and I have 0 to 5, then I'm left with 0 to 1, including the point 1, and then 2 to 5, including the point 2. If I take away the closed interval 1, 2, then I'm left with 0 to 1, not including 1 because that's taken away, and then 2 to 5, not including 2 because that's taken away. So you see that the complement of an open is closed, and the complement of a closed is open. So now the question becomes, let's say you have a space that's closed, and you take out the null set, right, which is intuitively nothing. The null set is closed in nature because it contains all of its limits, right? That's what it means for something to be closed. So you take out nothing, so that the complement, when you take out something that's closed, it becomes open. So if you have a set and you take out nothing, which is closed, it becomes open. But you didn't take out anything. So it's open at the same time. So it's open and closed, so it's clopen. And relating back to the idea space, it's like really similar to like a closed mindset and open mindset, where a closed mindset is like, man, I know everything there is to know about this, right? Like that happens to everybody, like including myself. I feel like a monkey and like an idiot 99% of the time. It's a great way to live. And then you have like that open mindset where it's like, oh, I'm eager to new ideas and everything. And the beauty of everything is you can go from a closed mindset to an open mindset by taking out nothing, which is just kind of crazy.
That's such a math trickery. That's such a math thing.
So
yes, it is.
That explanation was awesome, but I was thinking about something else the whole time. And here, okay, this might be like a lot to say, but I'm going to start with this. So in quantum mechanics, we have these Hilbert spaces where wave functions live. And the wave functions are kind of the objects that we study. And we have this like magical equation that the wave functions evolve through, I guess, which is the Schrodinger equation. It tells us how, if you know the wave function at some time, it'll evolve according to this equation. So in parallel to the idea space, is there some way to describe how the elements of the idea spaces evolve in time? Because I'm thinking about how before anything was alive in the universe, there was just no ideas at all. And then at some point there was the very first idea, and then all the way until now, is there some way to describe the way that very first element has evolved over time all the way until now?
Dude, fantastic question. This is there's a lot to unpack in that, and the way that I would say it is, so at the end of the book I have in the appendix a nice little theory that it's like, so the whole point of physics is, again, an approximation of what we see, right? And there's my little theory at the end is that our idea space is a reflection of the observable universe. So kind of like the way that ideas form is a similar way to the way that stars form, in the sense that the whole point of general relativity is like if you have a trampoline, right, and you put a bowling ball in it, it kind of dips, and then that's like a theory of gravity, right? The bowling ball you put some marbles around it, they'll spin around the bowling ball. And that's kind of what a star is, with all of the planets and everything around it. Same thing with a black hole or whatnot. So my whole idea is that even the same thing occurs within our idea spaces, where different ideas have different weight, right? And the identity of an idea space it's kind of analogous to a black hole, where it distorts and warps the idea space around it so much that you have all of these ideas kind of flowing around it. So for example, I think I sent you guys a couple quotes before this, but another, like an example of an identity would be one for wellness in general, for me at least, and everyone has a different identity based on their idea space, and it's everybody lives 2 lives, and the second starts when you realize you only live 1. And that's a quote by Confucius. And for me, that whole sentiment, because like there's more to just the thoughts, right? It captures the emotions, the sensations with that idea space. And so like a lot of my ideas on wellness revolve around that single identity, right? How do I live my life to a point where I've realized that I have 2 lives, right? That hit me when I first heard that. It was by Naval Ravikant, and that just changed my whole life. I was like, man, like, am I doing what I want to be doing? And it's like, it seems like you guys are killing it. You guys have a podcast, and you guys like have 400,000 downloads. Like, that's insane. You guys are just killing it. So I'm so happy to see, like, I love seeing people succeed, and seeing you guys do this is awesome. And again, having you guys letting me go on makes my day. So I hope that kind of answered your question, where it's like in the physical world we have weight and mass kind of decide how mass interacts with everything around it. But in the idea space, it's similar, except instead of measuring mass, you measure energy, right? You can get excited about an idea. Like you can see it. You can't measure it at all, but you have like this energy sensation.
I was just gonna ask if there was any, now obviously not yet, but like, do you even have like an idea for a for a way to possibly quantify like the energy of an idea? Now I know how abstract this sounds, but like, do you, because I mean you're writing the book, right? So do you at least have an idea that, okay, maybe this is what we can do? Like how do you think we weigh ideas? Like how do you think that happens?
Yeah, and it's tough because it's like the whole point of the idea space, it has zero measure, right? And something that has zero measure looks like nothing. So how do you measure something that looks like nothing, right? And I think this is where fractals comes into the picture, right? And if you're not familiar with fractals, for those of you listening, it's basically you have a pattern and you just repeat the pattern, and then that's kind of like the fundamental way of looking at it. But obviously, it's a lot broader than that. And you have like a simple question is like, how long is the coast of Great Britain? Well, the answer depends on your measuring stick, right? If I have like a 1 meter measuring stick, I'm going to get a lot smaller answer than if I have an inch measuring stick, right? So the question becomes, when you get into fractals, you get into this thing called Self-Similarity Dimension, which is basically the dimension of something like, for example, the Cantor set, right? It's the Cantor set basically is like you start with a line interval 0 and 1, you take away the open middle thirds, then you're left with 2 line segments, and then you take the open middle thirds of those 2, and then you're left with 4 line segments, and you just kind of keep taking away the open middle thirds, and you can get a self-similarity dimension of that, which is around 0.6309. So to answer your question, I don't think there is a way to measure like how exciting an idea is just because it has zero measure in nature, but I think a possible lead for it would be to kind of look at like follow the fractal approach to it, or the fractal mindset.
Mm-hmm. If you don't mind going a little deeper before you continue into the whole Cantor set and the whole idea behind a zero measure idea space, because I think the like that whole because these are like the macro properties, right, of these spaces. So I think it's really fundamental to understand this very well before we continue. So let me ask, like, what, because you briefly described the Cantor set. I just want to know, kind of like in your best way of explaining, what does it really mean to have a zero measure idea space? Like, what does that really mean?
Yeah, no, great question. So so the Cantor set, you start with 0 and 1, closed interval. Then you take away the open middle thirds. You're left with 0 to 1/3, and then 2/3 to 3/3, right? Mm-hmm. And then you just keep taking away the open middle third out of each interval. And the Cantor set is the intersection of everything as you go to infinity, right? So there's 2 questions from here. One, how many elements are there? Are there countable amount of elements or uncountable amount of elements? And 2, what is the measure of the Cantor set? So we'll start talking about the measure first, just because that's what you asked. So for something to have zero measure, let's say that I have an interval AB. The distance is defined B minus A, right? If the distance B minus A is less than epsilon for all epsilon greater than 0, then something has zero measure, which is like, in math, understanding that little epsilon greater than 0 trick is that's
it's basically
you'll get math
defining the words close enough. That's basically
exactly.
It's something that took us a really long time to really understand. I remember in first year, I only really got the whole epsilon thing as I was about to take my final exam, and I was like, oh, I can see it now in my head.
Yeah. I think like for me, so the way I wrote the book is there's like over 300 pictures in the book. Like a picture is worth 1,000 words and an idea is worth 1,000 pictures, right? So cool. I put a good drawing on limits in there that describes that. But like that's what something has zero measure. So the Cantor set, if you go all the way to infinity, there's no intervals. They're just dots. They're just endpoints. So it has zero measure in nature. And a good way of thinking about it is like Cantor dust. It's just kind of like whew, like just particles flowing around in space that has zero measure. And to get why the idea space has zero measure, I want you to look for something in front of you, and I want you to pick it up. Like, for me, I have this little almond thing, and I want you to hold it, and I want you to feel it, right? You can measure it. You can feel it. But now I want you to close your eyes. And then when you close your eyes, I want you to keep measuring it and keep feeling it. In your head, do you see a mental image of what you're holding?
I do.
Now the question becomes, can anyone see that mental image that's in your head?
No.
That's what it means to have zero measure. It looks like nothing, right?
Oh,
because
okay.
nothing
Yeah,
and
yeah.
zero measure look the same. And that's what I call in the book a topological singularity. It's something that has zero measure and is uncountably deep. And because it has zero measure, it looks like nothing, which is just like your idea space. Like,
But
yeah.
you can also say that for anything, though. Like, if I look at something, nobody will have that exact angle of that object that I have. So nobody can see the object like I see it. You know what I mean?
Dude.
But they can
Boy,
still
do
see the
I.
object. Right?
So this leads me into the Sunset Conjecture. So everyone lives at, so like, have you guys ever been on the beach and you're like walking at, and like it's like sunset and the sun's going towards you and you're like, damn, like this is a really nice sunset and it's going right towards me. Well, if you've ever been with a friend on the beach, he goes, no, the sunset's going towards me, you idiot. So that kind of goes into the idea everyone is at the center of their own observable universe, right? So the sun that's coming towards you is because you're at the center of your own observable universe. But what happens if you extrapolate that thought process farther, right? So the edge of our observable universe is something called the cosmic microwave background, which is the point at which the universe went from opaque to transparent. So from light just like not being able to move to light moving freely. So everybody has their own cosmic microwave background sunset. And then if you extrapolate a little bit further, you get a singularity is the hypothesized beginning of the universe with the Big Bang, right? So everyone is at their center of their own observable universe, and the singularity, which the hypothetical graviton broke off as soon as Planck time, so like 10 to the negative 44 seconds after the singularity happened, everyone gets a different singularity sunset, right? Everyone just, and that's what goes into exactly what you were saying, where you're seeing the thing, but you're seeing it from a unique lens that is only true to you. And I think that's like what's beautiful about being human. It's just like, for however, like we rely on words so much, but words can only capture a specific portion of the idea space. And that's why I think it's so important to use pictures, to use math, to use body language, to use tone, because although you'll never get a perfect transmission of my idea space to your guys' idea space, we can still get a common ground, right? And that's why I think koans and identity, because so a koan is kind of like a phrase that captures the identity of an idea space. And so like, for example, that everybody lives two lives, the second starts when you realize you only live one, that's a koan. And that's how you transmit specific sub-idea spaces from one person to the other. It won't always hit, right? But in sometimes it will, and those times are like, that's like the magic of being human, right? Being able to communicate to each other.
Sharing idea spaces. You kind of put that out there, and I just started to think about that. Now, very recently, we had the very first tweet that was sent out by someone's thought. I don't know if you guys been watching a lot of this, but that happened quite recently. Yeah, it was with the use of a brain chip on a paralyzed man who thought it and tweeted something. So obviously this is literally the first time this has ever happened, but I'm saying 300 years from now, I'm saying, what do you think are the possibilities of sharing such ideas? Now, I'm not again saying, just as you very well said, words can't really describe it. So I'm not saying I'm explaining my idea to you. I'm saying you literally like get an input of my idea in your brain. Like, what do you think that would look like? Do you think like that's like a possibility, a mathematical possibility? What are your opinions on something like that?
First of all, congrats to the team that figured that out. That's
right?
badass.
Right? Yeah. It was a big deal. Deal.
So my whole thing, so like the idea space is zero measure, right? So, and it's uncountable. So basically it's like, it's really difficult to transfer from one person to the other. But again, we have to remember that's just an approximation. It's not the end all be all truth. And I like the way Karl Popper puts it, where science is a world of conjectures and refutations, right? You put a bold conjecture forward and you wait for refutations to come in the form of different observations that prove it to be true or not true, right? Or just not true, because contrary to popular belief, science isn't about proving something true, right? It's about falsifiability. So it's like, if we can prove it wrong, then it's wrong. Like in statistics, you make a null hypothesis, and the null hypothesis is either you reject the null hypothesis, so it's not true, or you fail to reject. At no point are you saying it's true.
Exactly.
So to get to your question, it's like, according to the idea space theory, it would be very difficult, but I want it to be broken. You know what I mean? Like,
Yeah.
I think defining the idea space as having zero measure and being uncountable, like, I really wanted to drive people to like break it and be like, you know what? Screw you. You're wrong. Like, I'm going to figure it out. And I'll be like, yes, please figure it out. Like a TM in Pokemon where like, if I could just like learn a move, like cut and just chop down a tree, that would be legendary.
That would be very cool. Imagine like you're just like, hey, I want to be a warrior. Just download the skills. Like, how cool would that be? Like the muscle memory.
Matrix.
Like that would be so cool. Yeah, basically.
So what about this? Because like the physical world and what we see and feel and smell and all that stuff, those are, by your definition, those are all just ideas. And so my question, or I guess it's not really a question, but my idea is that like consciousness is basically the thing that is able to observe elements in the idea space. However, that kind of inverses the whole physical reality aspect to being alive, because now instead of things actually being things, everything is just an idea that is being experienced by consciousness in the idea space, which is just like some zero measure thing. So in reality, there is no out here. It's all just in the zero measure thing.
Yeah, so that's a fantastic statement. And so let me think about the best way to word this. So I agree with that those things are just appearance, because like, so in Buddhist philosophy, one of the main teachings is in seeing there is only seeing, in hearing there is only hearing, in smelling there is only smelling, in thinking there is only thinking. And that's exactly what you said, right? Like consciousness is the light or awareness that one shines onto an idea space. And that kind of like puts the whole question of I in question. Like, we're so used and accustomed to using our name and like just like who we are as a person, we have attached an identity to who we are. But if we take a step back, we're able to see that who we are is just another appearance in consciousness, which is kind of terrifying at first when you realize, okay, like me, I, is just an appearance of consciousness, just because there's so much attached to I, right? Like, who am I supposed to be? What am I supposed to do? But if you take a deep breath, you realize that it's actually pretty liberating, because you're able to kind of look at your idea space from fresh perspective. And to talk about what you said about how the world, you would think that like the world is a projection of your idea space. Two things that come to mind is, one, everything we see is in the past, no matter what, how far you are. Like me looking at this mic, this computer, it's in the past, which is kind of crazy in its own right. But then the other is like the world, we live in a clopen world, right? Like the world isn't true, false. The world isn't open, closed. We live in a clopen world. And the way that I view mind-body duality is that mind is open, the body is closed, and we can live clopenly between both. Because like we definitely have a body, like, I don't know, like there's something in there. And I definitely have a mind. I just can't, no one else can see it. And I think kind of like talking about what I was talking about before about Sam Harris, I think the finding a way to talk about mind-body duality in a very neutral way with Clopen is will be a good way of unlocking a lot of tension in people, because I don't know, like one of the big things I want for the idea space is to give a common language for mindfulness and kind of help spread mindfulness, because sometimes it's very viewed as like a very mystical thing. So I really want to demystify it and put it in a way where, you know what, like it is important to look at your own idea space and reflect on kind of like what you're doing. And just hoping that perhaps by building a more scientific framework that people, especially sometimes in like who are very, very scientifically oriented and kind of dismiss mindfulness as a thing, kind of just approach it with a new light. I'm not asking them to fully dive into it, but just kind of keep an open mind.
I'm thinking that this idea, like of the idea space, actually answers like a lot of questions, like philosophical questions, if you actually choose to believe in this theory of the idea space. Because I'm just thinking, like if you state, you know, that every individual has their own unique idea space, and I'm assuming you also believe given two idea spaces, they will always be unique, right? Like two separate idea spaces. So then, you know about those crazy philosophical problems, right? Where they're like, oh, you live your life, you take your brain, put it in someone else's body, see what happens. Are you the same person? A lot of this will be answered by this idea space. Because simply put, let me ask you what you think about such a problem. I forget what it was called, but it's like a very famous problem where like a mad scientist basically like swaps two people's brains. And the question is like, oh, like which one is which? You know, like is like if the mind of A went into the body of B and the mind of B went into the body of A, who is A and who is B? So with your theory of idea spaces, tell me how you would approach such a problem. Like would mind A that's now in body B, because like would it start to have, I would assume from any point onwards you have new ideas, right? Or if you're using the previous ideas, you have new ideas that are building onto your previous ideas, right? So if you're comparing anyone previously to someone new, how do you compare their idea spaces? Like this person died, let's say when he was 40, and then continued his life in another body. But do they have the same idea space? No. But are they the same person? Like how would you tackle such? I don't know if that question makes a lot of sense, but tell me.
No, dude.
It
That
does.
was a perfect question.
Tell me how you would tackle such a problem.
You guys asked some really good questions, first of all. So thank you for asking them.
Of course.
So the way I'm thinking about it, or it's twofold. The idea space is an approximation. Again, it's not like the end all be all truth.
That's important to know.
The real test is experience. It's life, right? Like, what do I see? What do I notice? What do I hear? What do I see? And the second point is the idea space is impermanent. So, and I think impermanence and accountability go hand in hand together. Like, you're not the same person you were 5 years ago, let alone 10 years ago. And you're probably not the person you were this morning, even though you might think you are. It's just like the idea space is always flowing. And that kind of touches really closely onto uncountability, where there's always like a new number that you didn't count or a new idea you didn't have, right? So putting those two things together to answer your question, I feel like it would still need to be tested, right? Like the idea space is just like, maybe that's the thing that like breaks the idea space completely, right? Like, again, I'm totally cool having the idea space be completely wrong, because the whole point of science is like falsifiability. Can you prove it wrong? But like, so in my mind, the majority of the idea space resides in the brain. Like, I'm still not like as abstract and metaphysical the idea space is, I'm still like I know like you have a left hemisphere, right hemisphere, and like depending on kind of like one shuts off, the other turns on, a whole different slew of things happen. But I would say, as a guess, complete guess, that if I transferred my brain and if I just transferred my brain by itself from one body to the next, I think you would get an amalgamation of idea spaces, just because of the nerves of the other body would be muscle memory, and those would kind of affect the idea space of one person. But if you were able to somehow, some way, get all the brain with all the nerves attached to it, maybe a different story. But like, this is because like I think this goes into, I think Parker, you were also talking about this too. It's like, what has an idea space and what doesn't, right? Like, when was the first idea space? So if you look back through time, and let's just start with the terrestrial options, life started around 4 billion years ago on Earth. That's possibility number one. Then a couple million or billion years after that, you get eukaryotic life, which is life with a nucleus. That's another possibility, right? So like the question, like there's so many different possibilities, or like, has consciousness always been there, right? Like Elon Musk talks about this. He goes, like, we went from hydrogen after the Big Bang to us now being conscious. Like, when did it happen? And like, clearly in my mind, at least, like dogs have an idea space, cats have an idea space,
100%.
Like plants, even like I remember seeing something crazy where like they played the sound of a caterpillar, not even just the sound, and the plant just produced a certain chemical that kind of like triggered it. I don't know if it's legit or not, so go find it on Twitter or some reputable source. But like, yeah, so it's like, that's like a huge question. It's like, what has an idea space, what doesn't? Are we simply the amalgam? Because like the way people talk about DNA and everything, it's like DNA is just a bunch of chemical processes, right? And then cells, they talk about, all right, cells are life. But then like, if cells don't have consciousness and DNA doesn't have consciousness, and we are just an amalgamation of cells in one way, shape, or form, like, do we not have consciousness? But then at the same time, if like cells do have consciousness and we have consciousness, does everything have consciousness? So it's like the question of free will is, in my mind, clopen, where we have free will and we don't have free will at the same time. It's like the world of true and false and yes and no and open and closed just gets shattered by the idea of clopen. And I think that's why clopen is so beautiful. That's actually the chapter of the book. It's called The Beauty of Clopen, just because it's like, damn, like, and all you have to do to get from closed to open is take out nothing. So you don't do anything, which is like, yeah.
So like a formal, sorry, but just one thing. So like a formal definition of consciousness, you're basically saying is you are conscious if and only if you have an idea space. That's a really good question. Is that what you're saying? Is that a formal way of saying that?
I don't know, because the thing that's interesting is an idea space and the elements of an idea space could have evolved differently than consciousness. So you could have a whole idea space, but something not be conscious, and then consciousness evolve separate of the idea space. You know what I mean?
So
you have thoughts, emotions, and yeah.
Because I'm just interested
like, I have no
in knowing
idea.
how you're defining how consciousness is defined with the idea space. Because it's not a direct link, right? Now I know it is kind of like adding like to the discussion. Yeah, so it's kind of adding to it, right? So I'm just seeing how we can differentiate it, because like I think a big purpose of this was to mathematically describe how we think, right? And a big question with that is, well, what is consciousness? Like, how do we, or like, we understand that, hey, I'm thinking of this thing, but how do we quantify? How do we actually formally state that this thought just occurred? And your way was the idea space. So I was just trying to think of a way that this consciousness kind of fits in to the idea space.
Yeah, no, that's a great question. And I think like we talked about, it's just like the light that one shine onto an idea space. And it gets really tricky to define things just because definitions are so fickle in nature. I think there's another good Karl Popper quote that like the way, I forget what it is, so I'm going to butcher it, so I won't say it, but like the basic gist is like, you can't really define something perfectly just because in order to define something perfectly, it has to be true in all situations. And like the only place where something can be true in all situations is usually just math, right? And physics is the applied math onto the world we see. And kind of what I was trying to go with the idea space, exactly what you said, Ray. It's like, how do we map mathematical concepts to consciousness? So yeah, I think it's like, we can define it as an approximation, but to give a very true definition, I think that can only exist in the world of math, just because like that's the beauty of math, right? And the weirdest thing is, math is also an idea space, right? But like math is like the scaffolding that builds idea spaces, but it's also an idea space in itself, which is like weird.
Okay, here is a visualization, and I've been dying to not forget what I've been thinking of. Okay, so I've been trying to think about what it means for something to be a part of an idea space. And so I started to think about, okay, let's pretend like an idea, or like the space in which idea spaces live is like three-dimensional, just so we can visualize it. And so like, what if an idea space, like my personal idea space, is just like a closed disk, and then elements that are like ideas that are floating around in the more general idea space are a part of my idea space if they intersect this disk. But then I started thinking about things like, what does it mean for an idea to actually be in my idea space? For example, I know that integers exist. I have never thought of the number 3,560,007. However, I still understand that that number exists, and also other numbers that I've never thought of. So like, what if you have like the number line that is in this like general space, and my idea space is actually more like the surface of a sphere, and so the surface of that sphere intersects parts of that number line, and so some of those numbers are actually, or have been, or are now in the idea space, but whatever is like inside the sphere that isn't actually intersecting my idea space is still somewhere within the bounds of my understanding. What do you think of that?
Yeah. So, like I was saying before, I think pictures are worth 1,000 words, right? And that's why I put 300 pictures in the book. And I think for me, the easiest way to describe an idea space is, let's say you start with a circle, just a circle. That's an idea. It can be a thought, emotion, sensation, perception, whatever you want. And then when two circles meet, what happens? The two circles, there can be either the union, right, where the everything from both circles get in, the intersection, where only obviously what's in common gets in, or the difference, where just the parts that are unique to each idea gets in. So then the key to the idea space is that like you can amalgamate those in all different ways, shapes, and form, and you just get like a 3D blob. And you can just do whatever kind of 3D blob you want. And I can send you guys some pictures of what that looks like afterwards if you're interested.
Mm-hmm.
But kind of continuing what you were saying, the whole point of an idea space is that it's a topological space at the end of the day. And what's a topological space? A topological space has to satisfy three qualities. I'm going to butcher the last two, so please bear with me. The first one is that the null set and the null set is in the space, and the collection of all of the elements are in the space. So if you have a circle, the null set's in the circle, and every element inside the circle is in the circle. The second is that the union of finitely many open coverings is in the space M, right? Let's say we have a space M. So, and then let's say you have like 10 subcoverings. That covers the whole space M. And then the last one is the intersection of any two open intervals is also within the space M. So those are the three defining properties. I might have butchered the last two. I might have flipped kind of like what those are, but we can Google them to be sure. But yeah, so like that kind of like builds a topological space. And the beautiful thing about a topological space, it doesn't need a metric. So it doesn't need a way to define distance between point A and point B. So there's no need to define the distance between one idea and the other idea. They can just exist, right? And if we were to put a metric on it, if we wanted to, it would be the pseudo metric, right? Where the distance between any 2 points is 0, because then that maintains the property that the idea space has 0 measure.
So why does an idea space have to be a topological space?
I don't know if it has to be. Again, it's just like an approximation. Like, how do we, like, Karl Popper said, a lot of Karl Popper for me today. Pure mathematics, which primitive proofs only give us ways to describe the world, right? So, again, it's just an approximation of just like, how can I describe consciousness in the most fundamental level? And I think topology is the most fundamental way, in my mind at least, of math, right? Everything, like, all of algebra kind of stems, whether you have groups or anything like that, stems from a topological foundation of how groupings work. So it doesn't need one, but just a way of describing it.
Wow. I'm trying to think of a question about like relating the idea space to, like, we know physical space kind of plus time, space-time, as something we experience. And where do these idea spaces kind of interact with space and time?
Yeah,
Like the
so
physical, like
kind
the
of like-
physical interaction is what you're asking about.
Mhm.
With the
Well,
your
not
physical and
it's
your
not
mental
necessarily a
interaction?
physical interaction, but you know, like how, because
Yeah.
we can kind of observe how space and time play together, but then when you introduce the idea space, how do these three things play together?
Yeah, so a couple of things from there. The first is that the idea space has 0 measure, so it doesn't actually affect space and time. It sits outside of space and time. Because if something has measure, it has mass, it has energy, it can kind of like the trampoline. It pushes down on the trampoline of space-time. So that's kind of like the first aspect of it. It kind of sits outside of it, which opens up a whole can of worms. And the second is like we still have a body, right? Like our mind body are connected. It's Clement, right? Mind body duality. And the beautiful thing about space and time is that or the rules of special relativity. So Einstein's equivalence principle basically states that on a really small scale, the rules of special relativity apply. So what does that mean? So let's say you have a stationary observer. You guys are just looking at me, and we're in the same room. Let's say I walk across my camera, right, from like left to right, like this. When I move in this direction, my body contracts in that direction relative to you two because you're stationary. And to make up for that contraction, my time slows down. So like that's like the twin paradox, right? If you have send an astronaut to space and he goes around the Earth really, really, really fast and comes back down, he's going to be biologically younger than a twin who was born at the exact same time. So kind of like bringing those two together, it's like you have a mind that somehow controls the body in some way, shape, or form. Still have no idea how that all works. But then like when you move in like the thing that's interesting to me is space-time is malleable, right? Simply by moving, by talking, by being human, we can affect the way space and time, like we can warp space and time around us simply by doing those things. So like that's kind of like how the idea space and space-time are related, because like everything we see is in the past. So like you get this cool thing where like if your idea space is the present, I don't really know if it is, like if it is, then you can kind of control what you do, and then that kind of affects people who are outside, right, in a very unique way. And it's like a very obvious truth, right? Like, no duh, if I do something, it's going to affect something else. But like on a very fundamental level, on a physical level, it's like looking at it through that lens kind of like reinvigorates the truth. And sometimes it's important to state the obvious, because if no one ever stated the obvious, then the obvious would be forgotten.
Very true.
That's powerful. I'm just thinking about the separate, because you were honing in on the point of, because you were also kind of briefly talking about how the idea space is separated, right, from physical reality, and it has to be due to the zero measure and all of the properties of it. But I'm just thinking about, like, you know, there are multiple theories that it reintroduce or like introduce a field, for example, on top of the universe that excludes something. For example, I was reading there's a theory that doesn't require that proved or doesn't require dark matter or something by simply putting a field on top of the universe and saying, oh, it's actually this field that's doing this thing. So in your case, to apply it is basically what you're saying is you're just applying this idea space to this universe, this separated field almost, because it's not directly on the reality field, right? So you're applying the separated field basically just to answer a bunch of these questions that we have about the reality in the first place.
Yeah, and the thing that's important to remember is that all the physical theories are all approximations. Like, they're not end-all be-all truths. And like the thing that's crazy to think about, like the concepts of space and time are also like human inventions in a way, right?
Think about it, yeah.
Like like the big question is like, what happens if you take out everything you know and you observe to what is actually given? What are you left with? And that's like what it means to be human, right? Like you have your sensations. Yeah.
So is there, and I've been wanting to ask this question because Parker and I have been talking about this a lot, and I just want to ask you, I don't know if this has something directly, but you just gave me this idea. Is there an objective truth to the universe?
I don't know how anybody could produce an answer to that.
My question. Okay, more specifically.
Yes.
More specifically in this
like
situation.
natural laws. Do natural laws exist?
Like not only natural laws, but like, for example, Parker and I were talking about, like, we talk about these ideas where it's gonna be funny because I think we've brought this out on a podcast before. Like, if a tree falls in a forest and nobody was there to see the tree, did it really fall? So my question is, if no one was really there to see it, so that means in this case we're also linking reality with your idea space, because obviously what you're saying is what you're seeing adds to your idea space. So I'm saying, taking out all of the idea spaces in the universe, that means, remember you said there's a personal and there's a macro idea space. So taking away the macro idea space in the universe, would there still be events or like by this logic, again, this is all opinionated, I guess, Parker, you're right. There's no real answer to this. But what do you think? Do you think that there is a reality that is simply dictated, that does not require these idea spaces to be there to occur? What do you think about that?
It's a great question. So I'll unpack it a couple different ways. So the first one is like, are there natural laws in the first place? And my answer would be no. And this is a good example Richard Feynman gives in his lectures. It's like when you think about the atom, right? Well, the Greeks thought about it was like a dot, a circle. But then Rutherford introduced it was like an orbit. But now it's like the quantum model is like an electron cloud. But then you look at the quantum field theory and string theory, it's like, oh no, it's fields. So like the deeper you study something, the falser and falser it gets. And that kind of goes into the uncountability of the idea space, where every idea generates a new idea, right? So I think it's impossible to define natural laws. But then to go to your question, it's like, if you're asking like, if there's no consciousness and there's no kind of like observation to something, like did it happen, or was it just yeah, that's like a fantastic question.
Yeah, we talk about
like
this a lot.
I don't know, cause
And
like,
also, if you think
Yeah.
about, if there exists a universe with no observers in it, does that universe actually exist? And another way I guess you can put it is that our universe, we can say, oh yeah, obviously our universe exists, and we can make predictions about how it started. But in reality, we can only see so far back in the past. And so what if at that point in time, at like recombination, which is, you know, what we see in the sky all around us, what if that's like a wall in time where like before recombination, it was just like a dividing by zero glitch where like all of the initial conditions were set, and then when like the video game was ready to play, it just started from recombination, and everything just evolved from there. The only
So,
thing we
yeah,
can do
that's
is really say like, oh, here's a natural way that the events could have played out from the very beginning, but we really don't know what actually happened.
yeah. So great statement, and a couple of things that come to mind. The first is like, when you say our universe, it's like, I think a common fallacy, because it's like makes sense, because like we all think we live in the same universe, but like everyone lives at the center of their own observable universe. So there's like a tiny bit of light that's hitting you guys that's not hitting me, and there's a tiny bit of light that's hitting me that's not hitting you guys, just because of the observable universe is always expanding, right? So everyone kind of lives in their own universe, which is kind of weird, but like obviously it's a lot of overlap. And the second point is, I think that's kind of what inflation is meant to be. So if you look at the Big Bang, it goes singularity, Planck time, grand unification epoch, inflation, and then you get the hot Big Bang model, and then you get the couple other stuff that's happening, and then the point that we can say we're pretty confident, by we I mean physicists, because I'm not a physicist, I'm just a dude who likes math and physics, is the electroweak transition. So I forget when exactly it happens. I want to say it's the electroweak transition. Actually, it happens at 10 to the negative 10 seconds after the Big Bang, give or take. And that's the point where, so grand unification is like when all the forces were basically one, other than gravity. After inflation, the strong force broke off, and then you had the electroweak force that were one, and then at electroweak transition, that's when those two forces broke apart. And at the electroweak transition, that's when the Higgs mechanism kicks in, and the Higgs is just a field that gives the fermions matter, that gives fermions mass, which are the quarks and then the leptons, and then it gives the W and Z bosons their mass. So up until that point, you can, in the laboratories, you can collide particles at those energies required to show that everything after that kind of like happens, right? But before that, it's still really hypothetical. And so the beauty of inflation is that it kind of like, it's like that reset that you were talking about, where like there's the good way of viewing inflation is like, let's say you have a picnic table and it's all bundled up together, right? Inflation is basically you take that, this is like a Hawking analogy, where you take the side, you kind of like make it really flat, really smooth, really fast. And so the way that works is kind of creates a whole, it's like a reset. And like, there's a huge depth of analysis that goes with inflation. That was an idea that was pioneered by Alan Guth in like the 1980s. And it's like some super smart people have like talked about it and different models for it, and kind of like different, like there's the idea of like when you create a black hole, it could create a new inflationary model, and like so like if you're trapped in it, like that's the inflation, and that's like it kind of resets the universe inside the black hole. But those are just like crazy, like it's hard, there's no evidence because we can't see in a black hole obviously. So yeah, that kind of goes into what you were saying.
So comparing the Big Bang to the theory of the idea space, I think that might be interesting, because the Big Bang,
Dude, yeah.
we were kind of honing in on the inflationary aspect of the Big Bang. So I just want to explore the possible inflationary aspect of the idea space, question mark? What do you think about that?
Well, that also like
Oh
has
my-
issues with the zero measure thing, right? Because what is actually expanding?
No, but I'm saying, I mean, I'm not
No,
necessarily...
so yeah,
Okay. Well, yeah.
so like that could
let me hear how you
the
say it. Let me
the
hear how
key
you
could
say it.
work like you could do it because right, like the whole point of the idea space is the distance between two objects is zero no matter what, right? So even if you expand a lot, it's still zero. And that's kind of like my thesis at the end of the book is that the universe and the idea space are symmetric. So like, for example, there's like the math. There's some math behind it. I can send it to you guys if you're interested. It might be a lot to unpack here, but essentially, it's like the question becomes like, how did the universe start? No one really knows. Like, did it come from a bouncing universe or did it go from nothing to something? Similarly, how does an idea space start? Like, when do you become aware of your thoughts, right? Like, where do thoughts come from? No one really knows. It's from nothing to something, or is it a bounce from an old idea space to a new idea space, right? And then the question becomes, so much more change in the first 3 minutes of the Big Bang of the universe than the remaining 13.8 billion years, right? And similarly with our idea space, more happens in the first instant that the idea space gets created than the rest of the idea space. So for example, if something unpleasant happens to you, how much time do you spend create fictitious scenarios in your head of like what could have actually happened, right? You're like, oh man, if only I said this, right? But like that's because like the first instant of that idea space just dictated the rest of that idea space. And so if you're the beauty of mindfulness is you become of idea spaces when they arise, and you can kind of limit those idea spaces from creating. And then continuing the thoughts that I was kind of talking about earlier, where it's like you have mass, and mass kind of like is a bowling ball and a trampoline, which is analogous to what space-time is and how stars and just mass dictates our universe. What if something similar holds true with our idea space, where you have ideas that have a heavier weight? And the math that I propose behind it is like, so you have the Cantor set, and the whole thing about the Cantor set is that it's the universal compact metric space. Because you can take a surjection from the Cantor space. You can take a continuous surjection from the metric you can take a continuous surjection, which is an onto mapping from the Cantor set to any compact metric space. So the question becomes, is the universe compact? Is the idea space compact? And no one knows, right, if the idea space is compact or not. But then the universe, Hawking and Ellis showed that the whole thing can't be compact. It just can't. And the question becomes, is our observable universe compact? So you were talking about the Hilbert space. So what's the Hilbert space? The Hilbert space is a complete inner product space. So complete space is a place that has all of its limits, and an inner product space is basically just the dot product. So the question becomes, how do you go from complete to compact? Well, the Hindboral Theorem states that if you have a closed and totally bounded complete metric space, then it is also compact. So for example, you have the real number line from negative infinity to infinity. That's not compact. But if you take the interval a, b, that's closed, that becomes compact. So if the observable universe at a specific point in time is a sphere in R3, right, just a sphere around us that's closed, then it becomes compact. So then you can do the continuous surjection from the Cantor set to the universe, and then you get a continuous surjection from a Cantor set to the idea space. And all Cantor sets are homeomorphic to each other, which is basically like, have you ever seen like the people take a trick where they take a piece of string and they make the Eiffel Tower out of it? Mm-hmm. Yeah, it's like, that's a homeomorphism, where it's like you're taking a set or a space and converting it to another space by like twisting it, bending it, but without puncturing it. So if all Cantor sets are homeomorphic to each other, and you have one Cantor set that's continuous surjection to an idea space, and another Cantor said that's a continuous surjection to your observable universe, then you kind of get like this reflective model. And that was a lot of math, and I feel like everybody's listening to this and be like, what the hell is this guy talking about?
No, I think actually
That was awesome. Yeah.
Our listeners love us talking about math. Actually encourage us to do so. So no,
Okay,
definitely
well, perfect
not
then.
discouraged at all. That's actually a very interesting way to think about like because I mean I was just hearing like multiple things, like the weight of an idea in this idea space, and like adding all these maps together. That's actually a pretty interesting idea, because I guess the next step would be to even further define this idea space and to understand how these ideas are weighted and whatnot, right? Like things that we were basically
Yeah.
kind of going over. That's a very interesting idea.
Yeah, I think this is only the beginning.
It would be
Lot
cool
to
to
go.
see if like these like primitive theorems about, like, okay, what I'm trying to say is that here's an analogy. So before we knew how to describe gravity, obviously people had ideas about, oh, things go down, So an analogy to like the idea space, like before we even had something to describe consciousness and where ideas live, people came up with things like the law of attraction. And it would be cool to like see the idea develop further, and then like the law of attraction like just falls from the axioms of what constructs the idea space.
Yeah, and I think this exactly what, like, the big question is, like, before Einstein introduced gravity, did gravity actually exist? Right? Like, and you might think yes, but like if you think about it, like no one really, gravity didn't really exist, and like that goes back to the whole thing where physics is really just an approximation for the world around us. And like I think the whole point of general relativity is to kind of like, it's the way that Steven Weinberg's RIP says it is like in one of the first pages in his book, says that like general relativity is really a theory of gravity. Like it makes gravity obsolete because gravity is just the warpage of space-time. So for example, if you're in a rocket that's accelerating at 9.81 meters per second squared, and you have a computer on there that tells you that you're on Earth, would you be able, and it's a windowless spaceship, would you be able to tell that you're on Earth? Just because you wouldn't, right? So basically what you're seeing is that gravity and acceleration are one and the same thing. So if you take a glass and you throw it across the table, right, the liquid in the glass is going to tilt one way and then tilt the other way, right? And if you were like a tiny species living on that, would you be able to tell whether that was due to acceleration or a gravitational force? Again, you don't know. So like that's why gravity is a pseudo force, and I think that's why physicists have been so hesitant to put graviton on the standard model, just because it's like, you know what, maybe it's not there. But then that's like the whole question of like quantum gravity, right? Like what happens below Planck scales of 10 to the negative 33rd centimeters? Do space and time split? Like no one really knows, and that's kind of like the big question mark in physics right now.
I think the advantage of what you're currently doing is that it doesn't necessarily need to comply with like all these various laws, because let me tell you, as you were saying, like what happens at this scale. So I mean, I mentioned this a lot because like I love to talk about this. Last summer I did this quick little research project with a professor from another university, and he was studying loop quantum gravity and its effects around like black holes. So like the whole research study, or like the study that I was performing in, was basically like what are the various equations of motion of space basically around these really tight singularities, around these basic space anomalies, right? Like, or as you said, like in these very small scales, like how do we quantize general relativity, right? And that's literally like that's what we were doing. And your advantage in this situation is that you don't really need to conform to any of that, because right now like people are creating these theories, people are creating the needs for all of these various fields and all these various things, because they're like, oh, it has to make sense with special general, with quantum, it has to make sense with everything. You are in a field where really nothing has been done, like it's all open to interpretation, because like who is defined consciousness, right? Who's even taking a step? Maybe people exist, they're at least not known to us. So like that's a very interesting space. Did you think about that like before even getting into something like this, that hey, no one's really dabbled with something like this, so I can basically theorize anything I want and see what happens? Like, was that a thought, or were you still like,
yeah,
let me hear that?
great use of the word dabble first. That gets a shout out. That's one of my favorite words. But no, like, to be honest, like I just like I just like needed to so Naval Ravikant, the same guy that I quote a lot, said that you got to find something that'll make you money while you sleep so that you don't sell your time, right? Time is the most valuable thing, not money. But the conundrum is that you don't realize that until you have money. So I was like, how do I like save my time, right? It's like I can't, like I can code, but like not the best coder, but like I read a lot, maybe I can try to write a book. So my whole idea was like, what are the most Lindy proof ideas? And Lindy proof is just something that had withstood this test of time. It's been here for a long time. It's going to be here forever. So math has been here forever. It's going to be here forever. The English language hasn't been here forever. It won't be here forever, right? So I just wrote about things that were Lindy proof. And I had no idea what I was going to get out of it, to be honest. I just like wrote. And then like I started putting the pieces together. And that's kind of like how the idea space came to be. But I think first of all, really cool research gig. That sounds like an awesome thing to learn about.
It was, yeah.
And like one of the theories I have, it's also in the end of the book, is like one of the conundrums with general relativity is that it's hard to describe quantum mechanical effects using general relativity, right? And I think the beauty of Clement does a really good job at that. So, for example, you get particle-wave duality. What is that? Basically, a particle can be a wave or a particle depending on kind of how you measure it, right? And so the way that Clement really ties into that really well is that let's say you have a space-time manifold. That space-time manifold is going to be Hausdorff. And what that means is that every point is disjoint from each other. So there's no overlapping of points. They're basically just like this perfectly. So every point is closed in nature, right? So what happens if you take out nothing from those points that are closed? They become Clement.
Yeah.
Yeah, so like then you get particle wave duality, right? You get open is a wave, closed is the particle, and then every single point in space-time, it's like, because like right now the whole thing is fields, right? You have quark fields, you have lepton fields, and like just all the different fields. So it's like you have like this other topological field of just like Clement, where if it's closed, it's a particle. If it's open, it's a wave. And if it's Clement, it's just the particle, the ability to be both, right? And obviously, that's just an approximation that's not written in textbooks. So like if you're listening to this and like trying to study for one of your QFT exams, just go read some Daryl Schroeder or someone else. They'll provide you better answers. And this, it's like, again, like physics is just an approximation of kind of what we see. And in my eyes, I think Clement does a good job of talking about discussing particle wave duality. But like, I think like if like a physicist hears this, he'll be irate and be like, no, you can't speak of this. So
yeah,
we're having fun here.
I guess to put like the final words to this podcast, where do you think this is going in the future? Like where do you hope to bring this theory?
Oh man, great question. Like I think it would be a dream if like others build on it, right? Like I think for me, I think it's just like the beginning of something new and something great. I hope, right? Like I'm biased, obviously, so take that with a grain of salt. But like I really hope like one day someone comes in and just exposes it for what it is. Like the way that like Stephen Hawking did Einstein's theory of general relativity with the large structure of space-time. Like that book is just like so good. Like it's just so good. So yeah, it's just like I think it's just like a starting point. And like again, I think I really want to demystify mindfulness in a way where people end up practicing and just kind of like take a deeper look at themselves and just kind of don't like they want more out of life just because like a lot of people I know, like they just spend a lot of their time drinking, especially in college. It's like it's just what happens. It's cool. Like it's fine. We all go through it, but like too much drinking can be bad, obviously, and then it like takes away. And then like a lot of my friends, like I know, like they work 9 to 5 and they just like do that lifestyle, and it's just I want to like just tell people that you don't have to be a mathematician to understand math. You don't have to be a physicist to understand physics. If you open up the bridge between idea spaces, then you'll really be able to understand whatever you want. Like, you won't be able to understand everything, but you'll be able to understand more than you didn't know. And I think that's really important for people to kind of just go out there and try new things and follow their passion. And I think that would be like the ultimate goal from the book.
I think that's a nice way to put it. Like, a nice way just to live life is just keep increasing your idea space, you know? Like, that's just a nice way. Like, don't do anything that you've already done that already seems meaningless. You know, explore new things, you know, attempt new tasks, go on new adventures and stuff like that. So I think that's a really nice, concise way to do it. It's very interesting. I definitely want to see. First of all, definitely let us know when the book gets published. That would be definitely.
If you guys want, like, I'll send you guys before it gets published, I'll send you guys a copy of it. Don't worry.
That would be wonderful.
So like, I just have to be mindful, because if anything goes on the internet before I publish, then I can't publish it. So that would.
I mean, you can trust.
Me,
I don't know why we would post anything. Of course, we can trust us, but that would be really.
Yeah, but you guys will get a copy for sure.
Yeah, so I'm very interested to see how, like, you know, the future of consciousness can tie in with this particular idea, because I mean, I really see a lot of precedent, like not precedent, the wrong word, but like a lot of gravity in this field and in this theory, you know. Like, I really appreciate it, and I will definitely, I mean, keep continuing to work on this theory, and, you know, see if where you can take it. Very, very exciting stuff. Very exciting stuff.
Yeah, thank you guys both for having me on here. It's been a blast. You guys have asked incredible questions. You guys are killing it, and like, keep killing it. Like, keep doing the podcast.
Thank you.
Like, you guys are living life.
Thank you.
That's the way to do it.
Thank you so much.
Well, it was awesome to have you on. If people want to find you, where can they find you?
Yeah, great question. So mostly on Twitter. So you can follow. My name is Clement Decrop, which is a little tough for people, especially in the States. So my Twitter handle is @creamofdecrop, DECROP. And yes, I'll text you guys. I'll send you guys my info too if you guys need it.
Yeah, we'll be putting it all in the description, so don't really worry about that. Like, if you have any additional things that you wanna just showcase yourself on, it'll all be in the description below. Also, like, your name will be on the title itself, so that's all right. Anything else that you wanna mention to our listeners before?
I'll end on a koan, like an identity of an idea space, a big one that's, I think, really important. It's by Naval Ravikant, and he says, the means of learning are abundant. It's the desire to learn that's scarce.
Oh, that's powerful. Oh, that's powerful. Oh, this literally applies to our last episode, because we literally spoke about all the various resources to learn physics. So, like, the means are abundant.
For university.
It's all about the desire.
Exactly.
It's all about the desire. That's a really good quote. We can end it there.
So if you're listening to this episode right now, make sure to rate it 5 stars on Spotify, subscribe, follow everywhere, leave a comment. And this has been episode number 94. Yes.
Yeah.
I am your host, Parker.
And I'm Ray, and we will see you soon.
Bye, guys.
See ya.